Hello everyone. Today we are going to start with the third lecture and topic is double integral. Case number 3. In this case the limits of x are dependent, that means they are variable, whereas the limits of y are constant. Okay. So we'll take a question to solve this type of problems. So here we have to evaluate integral 0 to 1 0 to 1 minus of y e raised to power 2x plus 3y dx and dy. So here it is clear that we have to take integration with respect to x as well as the limits are in terms of y, that means they are the limits of x. So when we are integrating with respect to x, so we have to keep y as a constant. So it will be written as 0 to 1 0 to 1 minus of y e raised to power 2x into e raised to power 3y dx and dy. Now this is a constant part. So integral 0 to 1. Now when I take integration with respect to x, so this is a constant. So e raised to power 3y is constant and del of e raised to 2x will be e raised to power 2x over coefficient of x, that is 2, within the limit 0 to 1 minus of y, and then we have dy. So this 2 I have taken common, 0 to 1 e raised to power 3y. Now upper limit, it will be e raised to power 2 times 1 minus of y minus e raised to power 0 into dy. That will be 1 by 2 integral 0 to 1. It will be e raised to power 3y into e raised to power 2 minus of 2y minus e raised to 0, that will be 1 into dy. Now just expanding the brackets. So 1 by 2 0 to 1 e raised to power 2 minus of 2y plus 3y minus e raised to power 3y and then dy. So it will be 1 by 2 integral 0 to 1 e raised to power 2 plus of y minus e raised to power 3y and then we have dy. Now integrating with respect to y. So when we are integrating with respect to y, so 2 will be a constant, e raised to 2 as it is, plus y divided by coefficient of y, that is 1, minus e raised to power 3y divided by coefficient of y, that is 3, 0 to 1. Now using upper limit minus lower limit, now upper limit is 1, so it will be e raised to power cube minus e raised to power 3 by 3 minus lower limit 0. So e raised to 2 plus 0, that will be 2 minus e raised to power 0. So 1 by 2. Now 3 ones are 3, 3 minus of 1 2, so it will be 2 by 3 e cube, and then we have minus of e square minus of minus minus plus 1. So this is the result for this question. Or what we can do, we can just expand the bracket, so we will be getting the answer. So if I want to expand the bracket, so 2 and 2 cancel, 1 by 3 e cube minus 1 by 2 e square plus 1 by 2. So this is an answer of this question. Hope it is clear to everyone. Now we'll take one more question of the same category, but statement form is quite different. Now question is, evaluate double integral over the surface or region R root of xy minus of y square into dx and dy, where S is a triangle with vertices 0 0, that is origin, 10 1, that is the coordinate, and the last coordinate 1 and 1. These are the three vertices of a triangle. So first of all we plot the diagram and then we will solve for the limits. This is your x-axis, this is your origin, and this is your y-axis. So first point is 0 0, so that means I'll take this one. This is our origin 0 0. Now second is x10 y1, x10 y1. So this is your 10 and 1. Next is x is 1 and y is 1, x is 1 and y is 1, something over here. So I'll just do one thing, I'll take this value a little bit up so that it will be more easy to plot the diagram. Now the next point is x is 1 and y is 1. This is x1 and y1. So this is a triangle, this is point A, this is point B. Now the one thing is that from A to B, the value of y coordinate is same, 1 to 1. Okay, and only the value of x is varying from 1 to 10, and here from O to A the value of x as well as value of y is varying 0 0 to 10 1. Okay, so what I do, I'll consider a strip, horizontal strip in this case, because we have P and Q. Okay, so first of all, here in this case we don't have any limits. That means it's our choice to take either the limit of x or the limit of y. Okay, so I'm going to take the limit of y as a constant and the limit of x as variable. Okay, first of all we'll find the equation of lines. So equation of in triangle OAB. Now equation of line, let be OA. So this is a 2-point form. So formula will be y minus of y1 is equal to y2 minus y1 over x2 minus of x1 into x minus of x1. So y will be 1 by 10 of x, or we can say x is equal to 10 by. This is one of the value of x, an equation of line OA. Now equation of line OB. So it will be again y minus of y1 is equal to y2 minus y1 over x2 minus of x1 into x minus of x1. So it will be y is equal to x, or we can say x equal to y. And the variation of value of y will be from 0 to 1. Maximum value of y is 1. Therefore, for that, let us consider a horizontal strip PQ such that, now keep one thing in your mind, whenever we are taking horizontal strips, so we have to move from left to right, never Q to P, always from P to Q, left to right. And if you are taking vertical strip, so we have to move from down to up. Okay, lower value to upper value. Now let us consider a horizontal strip PQ such that at P, at point P, so what is the value of x at point P? So at point P, that is line OB. On line OB, the value of x is y. The value of x is y. And at point Q, the value of x will be 10y. Okay, so that means x is varying from y to 10y. Therefore, the surface is in terms of x and y, that is the Cartesian coordinates, and x is varying from y to 10y, whereas y is varying from, now the limit of y is from 1 to the variation of y is from 0 to 1. Okay, 0 to 1. So the integral reduces to 0 to 1, then y to 10y, and we have a function xy minus of y square root dx and dy. Okay, now we have to integrate with respect to x, keeping y as a constant in this case. So 0 to 1. Now when I am taking integration of this one, so we have a root first of all, so it will be xy minus of y square raised to power 1 by 2 plus 1 over 1 by 2 plus 1 into the coefficient of x, because we are integrating with respect to x, so coefficient of x will be y within the limits y to tan y into dy. It will be 1 by 2 plus 1 3 by 2, so it will be 2 by 3 0 to 1 xy minus of y square raised to power 3 by 2 into 1 upon y and dy. Okay, within the limits y to tan y. Now upper limit minus lower limit 2 by 3 0 to 1. Now upper limit is tan y. So tan y into y, tan y square minus of y square raised to power 3 by 2 into 1 upon y minus. Now lower limit y into y square minus of y square 0 into 1 upon y, and then we have dy. So it will be 2 by 3 0 to 1 tan y square minus of y square, that is 9y square. 9y square root will be 3y, so 3y cube into 1 upon y and dy. So it will be 2 by 3. Now 3 cube will be 27, integral 0 to 1 y cube into 1 upon y dy. So 3 1s are 3 9s are 9 2s are 18 times 0 to 1 of y square dy. So 18 times y cube by 3 within the limits 0 to 1. So 18 by 3 will be 6, and upper limit minus lower limit. So the value will be 6. Now since we are calculating the area, so 6 square units will be your answer for this question. Hope it is clear to everyone.